Our energy system responds in different ways to exercise. We need to produce ATP so our muscles are able to contract. In each energy system, there will always be a dominant one. ATP is used in the sliding filament theory of muscular contraction, as it binds to myosin to form the crosshead bridge. It also helps break the bridge after the power stroke so muscles can contract over and over again. It helps during muscular contraction as it breaks the crosshead bridge after the power stroke. It also helps when myosin is binding during the sliding filament theory. During activity, it will last a maximum of 3 seconds of maximal intensity. It's ready to use and in the muscles, the fuel is. However, it is hard to split the ATP, as it is hard to split a phospho from the adenosine. An advantage is that it is in the muscles, ready to use, and it is recoverable quickly. However, a disadvantage is that it lasts for 3 seconds, and they are connected by high energy bonds, and so it's hard to split. ATP resynthesis, phosphocreatine. Phosphocreatine helps resynthesize ATP. ADP, which is ATP without one of the phospho, makes ATP plus creatine. It is simple to split the P and the C during this. However, one negative is that the ratio of P to C to ATP is 1:1, so it is not the most efficient. It also recovers quickly. This will allow 3 to 10 seconds of maximal power and intensity. It is in the muscle sarcoplasm, so it isn't instantly available. However, it is very quickly available once. ATP can make energy plus ATP, a phospho, and ATPase, which is an exothermic reaction. However, when resynthesizing, you need ADP plus a phospho and energy. This will make ATP. This is an endothermic reaction, which means it takes energy in. Because the first one produces energy, that means it's exothermic. However, when you combine both of these together, it's a coupled reaction, as it is both endo and exothermic. ATP resynthesis and the glycolytic lactic acid system. You start off with glycogen, which is 6 carbon. You put in 2 ATP to gain 4 ATP, so you get a net gain of 2 ATP. The enzyme that is needed to convert glycogen to glucose is GPP, glycogen phosphorylase. Once it's at glucose, which is also 6 carbon, the enzyme of PFK, which is also known as phosphofructokinesis, is then converted the glucose to pyruvic acid. If there is no oxygen involved after this point, it's anaerobic, and the enzyme will then convert the pyruvic acid into lactic acid. This enzyme is LDH, lactase dehydrogenase. This will inhibit the GPP and the FPK so that it can no longer last, and after a while the lactic acid will be too much and you'll have to stop. This is used for high/medium intensity. The glucagon is in the muscles, so it's ready to be used quick. However, a disadvantage is that the lactic acid buildup will cause fatigue and heavy muscles. This will decrease the performance, therefore you won't perform as well. During a sport, the dominant system will vary between each event. For example, in a football match, one of contractions that will last less than 3 seconds will mainly be the ATP system. For example, during a goal kick of a football match, the ATP system will be dominant as it is a fast and instant contraction with low intensity. During short sprints that may last between 3 to 10 seconds, the PC system will be very dominant, as it is the same duration that the system will last. The glycolytic system, however, will be used during longer sprints that would last more than 10 seconds. For example, running to attack, but your team loses the ball, so you have to run back and defend. The PC system will be dominant when an attacker is chasing down a football. The aerobic system, which is when oxygen is involved, will be used generally during the match for phases when there's lower intensity for longer durations. For example, just jogging around the pitch when your team are attacking. During this, our investigation can show which system is being used. For example, during the multi-stage fitness test on the left is high duration and both low and high intensity. During the low intensity phases, there is a low amount of lactate buildup, as you can see at rest and at level 4. This is because they're using ATP in the muscles for the first 3 seconds of the event, and then for the next 7 to 10 seconds, the PC system will be used. For the rest of it, the aerobic glycolytic system will be used until the intensity is too high and the system is too slow at producing energy. At this stage, the intensity is very high, so the lactic acid / glycolytic system is used. This would then suggest, as the post-test score is very high, that the lactic acid system would have been used, as there's a byproduct of lactic acid which would suggest the build-up of lactate during the multi-stage fitness test. However, this is similar of the blood lactate during the Wingate test, as it is a low duration but very, very high intensity. For the first 3 systems, we would say that the ATP is the only system being used, the ATP system is the dominant system, and the others are just less effective at this time. For the next 7 to 10 seconds of the event, the ATP system is dominant. After that, the anaerobic glycolytic system is used. This would then suggest a sudden build-up in lactic acid. We know that it's not the aerobic glycolytic system, as it takes a lot longer to get into full force and the intensity and duration just doesn't fit it. Thank you for watching.